Alright, we're going to be looking at the unit circle and how that relates to finding the sine and the cosine of different angles. Notice in this little drawing I've put the quadrants. You have to know the signs of x and y in each quadrant, which I think most of you do. Remember, the radius of the circle is 1, and it's always centered around 0, 0. This is a review of special triangles you learned in geometry. One of them was the 45, 45, 90 degree triangle. And I've inscribed it there in the circle, so you'll see sort of how it's going to relate to the unit circle. We'll be using these special triangles to help us find coordinates on the circle. So, how is this going to help us? Well, the sides of a 45, 45, 90 degree triangle is the square root of 2 over 2 when the radius is 1. The other triangle is 30, 60, 90. I've inscribed it there, and the side opposite 30 degrees is 1/2. The side opposite 60 degrees is the square root of 3 over 2, and of course that's when the radius is 1. And this is actually the same exact triangle, but I'm just trying to show you if it was a 60 degrees at the origin, then it would be centered more like this, and the side opposite the 60 degrees is still the square root of 3 over 2, but that would relate to your y coordinate, whereas 1/2 is on the x-axis, so that would relate to your x coordinate. Other things you need to know. The x relates to cosine, and the y is sine. That symbol is theta, which just relates to angle measurement. And we're going to talk about some coordinates for what I'm going to call the cardinal points: 0, 360, 90, 180, and 270. So if the radius is 1, when x is 1, y is actually 0. And that's at the 0 or 360. The coordinate for 90, when x is 0, y is 1. When we're at 180, then x is -1 and y is 0. Finally, at 270, we have 0. When x is 0, y is -1. So I'm going to go through that again, but relate them to cosine. So if I asked you for the cosine of 0 degrees, you would say that it is 1. The sine of 0 degrees is 0, because that would be the y portion of a coordinate. 90 degrees, well, what's the cosine? Since x is 0, that's the cosine, 0. When x is 0, y is 1, so the sine of 90 degrees is 1. At 180, we are now -1, and the y value is 0. The sine of 270 would be 0. Sorry, the cosine of 270 is 0, but the sine is -1. And at 360, we're back to the beginning. X is 1, y is 0. So if I asked you for the cosine of 360, you would say 1. If I asked you for the sine of 360, you would say 0. So we're going to go through this with all of the, with various degrees and examples. Remember, here we're saying theta is 60 degrees. So the first thing I have to do is draw the 60-degree angle. The terminal side is at 60 degrees. And if I use my special triangles, I can find the coordinate for x and y by using the sides of that triangle. So, in blue, I've made the triangle, and I'm trying to help you see that the x portion of that triangle, the x-axis, is 1/2, because that's across from the 30-degree angle. Across from the 60-degree angle, the longer side is the square root of 3 over 2. So, if I asked you for the coordinate, you would say 1/2 comma square root of 3 over 2. What are the coordinates for 225-degree angle? Again, first thing you do is actually make it. The terminal side is at 225. And now hopefully you can see that I made another triangle. The radius is 1, that's the terminal side. What are the degrees of this triangle? Well, you have to think about how far past 180 are we. And hopefully with a little math you say 45. So what are the sides for a 45-degree angle? The square root of 2 over 2 would be those legs if the hypotenuse is 1, which it is. So, now the question might be, well, where did those negatives come from? And that's where you have to remember your quadrant signs. If I'm in the third quadrant, then my x and y are negative. So the cosine for this 225-degree angle would be negative the square root of 2 over 2. And the sine would be the same, negative square root of 2 over 2. So let's find the cosine and sine of each of these angles. What about negative 60? Again, you have to know how to draw the angle. In blue, I've drawn that reference triangle. The reference angle we're using is 60 degrees. And I've tried to even draw that blue triangle there to show you how it's oriented in the unit circle. So, the portion that relates to the x-axis is 1/2. The portion that relates to the y is the square root of 3 over 2. Remember your signs. In the fourth quadrant, it's x is positive and y is negative. So we have a positive 1/2, but a negative the square root of 3 over 2. And of course, if I asked for the cosine, you would say 1/2. Or if I asked for the sine of negative 60 degrees, you would say negative 3 divided by 2. Hopefully you can see there's a lot of repetition. Knowing these basic triangles is what really makes this rather quick. 135 degrees. Again, we got to draw that the angle in the unit circle. So our angle measurement is there. The terminal side is at 135. Now you have to draw a triangle. And the reference angle you're using isn't 135 degrees. It's that portion from where you see the blue triangle there. How many degrees is that? Well, hopefully you're thinking it's 45 degrees again. Notice, too, that these triangles are always drawn down towards the x-axis. A common mistake is to want to draw a horizontal line. You never do that. You always draw a vertical line to make the triangle, and it always relates to the x-axis. So there's our reference triangle there, trying to show you that's 45 degrees, and it's in quadrant 2. So that's negative and positive. And 45 degrees is the easiest one, I think, because it's the square root of 2 over the square root of 2. In this case, we have to remember our signs. The x, or cosine, of that 135-degree angle is negative, and the sine is positive. All right, what about 390? Well, now we've gone more than one revolution. And what is our triangle? Well, making a triangle down from 30-degree terminal side, we go to the x-axis, and of course that's just 30 degrees. The 1/2 relates to the rise there of 1/2, the y value. The x value there would be the square root of 3 over 2. So again, a lot of repetition. All right, let's draw a negative 240-degree angle. At negative 240, we are at the same location, terminal side. If you remember coterminal angles to 120, not that that matters, just sort of a review. where am I going to make the triangle? Hopefully you're saying from 120 down to the x-axis. And there it is. So that angle in green there is 60 degrees. In the corner, I drew the 60-degree triangle again, showing you the orientation. The y value is the square root of 3 over 2. Hopefully you're remembering the y value relates to the sine. The cosine is negative 1/2, because those are the signs that are necessary to be in the second quadrant for x and y. So I'm doing a couple more here, the procedure review. If we have a 315-degree angle, in this example, we make that angle. Then we draw a reference angle or triangle. Depending on what quadrant we're in, we'll determine signs, but we always head towards the x-axis. So you can see the blue line attaches the terminal side to the x-axis. How big is that angle? Well, that's 45 degrees. So what are the signs for that? Plus, x is plus and y is minus. 45 degrees, both of the legs are the square root of 2 over 2. Because the hypotenuse is 1. Remember, that's why this is a unit circle. And let's state that as co-coordinate. The square root of 2, comma, negative the square root of 2 over 2. And that's it, folks. Remember, we only fail when we stop trying. I hope you all have a great day. Thanks for watching. And if you made it to the end of this, you're my math hero. All right, you guys take care. Have a great week.